This is a problem regarding inverse functions. It comes from Chapter 5 in the book, Section 1. The first thing that we want to do when the book asks us to determine whether something is one-to-one is to put the function in the calculator. As you can see, let's take a look at our problem. Our problem is a rational function. When we have a rational function and we put it in our calculator, we want to make sure that each part of the fraction has parentheses around it. So I've taken my calculator and I've put this function in the calculator, x plus 4 divided by x minus 3, and I'm going to hit graph. Now, if you remember from the first chapter in the book, when we want to determine if something is a function or if it's one-to-one, we take our pencil and we slide it across vertically to determine if something is a function. If we want to determine if it's one-to-one, we want to take our pencil and slide it horizontally across the graph, because if it was a function and its inverse is a function, then if we turn our pencil the other way, our inverse would be represented by a function using the horizontal line test. So we want to take our pencil and run it horizontally across this graph. When we do that, it only crosses in one spot, so we know that this one is one-to-one. That's the first question we want to answer. If it is not one-to-one, if we take our pencil and we run it horizontally and it crosses in more than one spot, we wouldn't have to do anything else with this problem. But since it is a one-to-one function, we're going to have to continue with the rest of the work. So, for the next step, we're trying to find the inverse. We take all the y's and the x's and we switch them out. Remember that f of x is actually y. So what I've done in this next step is I've just taken f of x and I've changed it to a y. Everything else is exactly the same. We want to reverse those, so all my y's will become x's, all my x's will become y's. So that's what I've done here. Now, for the last part of the problem, what you want to do is you want to work on getting y by itself. When you see something like this, since you have two y's, and it looks like a proportion, because remember, this x right here really has an imaginary 1 underneath it. We take a look at that. If we draw a 1 underneath that x, we actually have an imaginary 1 here. So this is actually a proportion. And remember, with proportions, you can cross multiply. So we could take our problem and we could cross multiply. And if I cross multiply, I get x times y minus 3 and y plus 4 times the imaginary 1. And when we do that, algebraically, we can distribute the x. So we end up with xy minus 3x. We still have our y plus 4 over here because y plus 4 times 1 was y plus 4. Now we have to try to work on getting the y by itself. So what we want to do first is get all the y's together. So that's what I've done. I've just moved things across the equal sign to get the y's together. Remember, when you move something across an equal sign, it's going to change its sign. I really only want one y. So what I want to do next is I want to factor out the y. Now keep in mind, most of these problems will not be this complicated. But what I want to do is factor out the y so that I'm left with a single y instead of two y's. You factor out the y and you have y times 1 minus x over here. The left side still stays the same. We're trying to get the y by itself, so since this is multiplication, I can divide both sides by 1 minus x, and I will be left with a single y by itself. So my final answer for the inverse is negative 3x minus 4 divided by 1 minus x.